Welcome to this video, all of you. And in this video, we are going to understand what is machine learning. And I'm sure a lot of things you might have heard about machine learning. I want to clear out all the doubts. Now, in the previous video, we talked about like what is artificial intelligence, and from that video, we understood that artificial intelligence is making a human-like behavior from the machine. I'm expecting to make machines which can mimic very much like human. And if you peel off artificial intelligence, you will get natural language processing, computer vision, actuators and sensors. And then you also pick up one brain-like structure, which is machine learning. And this machine learning is something which I'm trying to explain over here, right? What is this machine learning and why we are even talking about this, right? So first thing first, we'll talk about this machine learning. When I say machine learning, this is not the complete name of it. The complete name of machine learning is machine learning algorithms. And when I say algorithm means the set of rules. Now, what kind of rules are being set up in machine learning is something which has a close relationship with what kind of problems we are sorting. So let's understand this machine learning thing, and I want you to remember this concept that it is nothing but machine learning algorithm, not only machine learning. Now, what is machine learning? If you talk about the definition, it says the machine learning is nothing but a branch of artificial intelligence which concern the construction and the study of the systems that can learn from the data. Very much like human, I want my machine to learn from the data. And I just wanted to give you one example, right? How this machine learns, with respect to the data. So just think about the way human learns, right? And we learn by looking at things, we learn by listening to the things, we learn by doing it, and we also learn when somebody teaches us and somebody gives us some certain examples, and we kind of learn that perspective. And there are certain things which we learn from with our experience. For example, if there is a kid, if you keep on telling that kid that, you know what, kiddo, just look at this surface, this is hot, you shouldn't be touching it, he or she might not understand. The kid doesn't understand that the surface is hot unless he touches it or he feels the burning sensation. Once he feels that burning sensation, then he understands whatever is being told is actually called as hot. So whenever I see this kind of surface, I call it hot surface, and I'm not supposed to touch it because it will give me a sensation which which is very troublesome, or which may give me some kind of uneasiness. So the kid learns it by just doing the task. Or when somebody is giving some kind of instruction, whatever you're doing, you are trying to connect with that information, and then you learn that particular process. Very much similar to that, machine learning is also making these computers understand what is what. So let's dig in deep into machine learning and understand more what exactly machine learning is, and how does it make a computer or a machine understand that what is what, right? So let's see the learning process. So we'll go through the definitions of it, and I'll explain you those definitions, and after explaining those definitions, we'll also see the types of machine learning and then application of machine learning. So machine learning is programming computers to optimize performance criteria using example data or past experience. And if you notice this definition is closely related to what you have seen in analytics. You're correct. I'm taking you to a point wherein you can understand that machine learning can be utilized for certain analytics purposes as well. So machine learning is programming computers to optimize the performance criteria using example data or past experience. Now, this is one definition. The other definition is the goal of machine learning is to develop methods that can automatically detect patterns in the data, then to use the uncovered pattern to predict future data or other outcome of interest. And I find this definition much more accurate than any other definition. However, I will read out other definitions as well for you. The field of pattern recognition, which is concerned with the automatic discovery of regularities in the data through the use of computer algorithms, with the use of these regularities to take actions. Now just think, for example, I know a kid, right? And I just wanted to make that kid understand how a dog will look like. So I just take that kid out and I show that dog to that kid and say, hey kiddo, just look at this animal, this is called dog, right? And what happens in the mind of that kid, I don't know, right? But he understands some pattern. And just imagine that I keep on doing this same thing for 20 days, and every time I show him a dog, I keep on saying, hey kiddo, just look at this, this is called dog. Now after 20 days, when I on 21st day, if I see a dog and I ask my kiddo, and I would say, hey kid, just tell me what's that animal called, and you guessed it right, the child might have learned the pattern and said that it's a dog. Now the point which I'm trying to make over here is that I want to collect some data, right? I want my kid to collect some data and detect the patterns, how a dog looks like, and then as soon as he sees the same pattern, it will recall whatever I called it, that whatever I call that animal, and then comes up with a label or an the name of that animal, and speak it out and says that, okay, this is dog. So the goal of machine learning is to develop methods that can automatically detect patterns in the data. Now for us, whenever we see something in the form of images, we detect patterns out of it. And if you closely understand the behavior of the human, if I identify my friend, I'm also detecting some patterns. How does he look like? He has specs, he has got some beard, this is the hairstyle, this is how he dress up, this is how he talks. I'm detecting patterns, and as soon as I see those patterns, I can simply say that's my friend. I can detect patterns even in his conversation. So I just wanted to detect the pattern, and I want to label that information as my friend. So the goal of machine learning is to develop method that can automatically detect patterns in the data, and then to use the uncovered pattern to predict the future data or other outcome of interest. Now just think, in the previous example where I'm teaching my kid to understand what is how a dog looks like, in that thing I have given 20 days, I have given some data to my kid, and I just keep on labeling that information, keep on naming it. And on 21st day, when I see an unknown animal, and most probably it is dog, an unknown animal, and I ask my kid that, do you recognize that animal? And he or she will say that it's a dog. So basically I wanted to predict my future data, which is unknown data, based on the past results which I have understood. Now for us, any visual or any I would say any data or any other thing is actually in the form of images, but for a computer everything is number, everything is 1 0, everything is in bit code or byte code, you can understand. Now I need to make sure that my computer understand that image or that pattern in terms of numbers. So that's where the difficult part is. So we'll see like how we can cover that up. Now if you just simplify it to a non-technical person who doesn't understand what is what, I can just simply say machine learning is about predicting the future based on the past, right? This is the most accurate definition for somebody who is very layman or who is initiating with machine learning algorithm. Now if you just peel it off, right, all the definition, if you peel it off completely, you will find algorithms or techniques. Now remember, machine learnings are algorithms. Algorithms are nothing but the set of rules. There are some set of rules which you will follow, and then you can predict the future. So algorithms or techniques that enable computer or a machine, in this term I can say computer or machine, the same thing, to learn from the data related with many areas such as data mining, statistics, information theory, etc. Now to uncover that futuristic trend or the patterns, I use many techniques such as data mining, statistical information, or information theory, or statistics, or you can say maths and some part of linear algebra or differential calculus. So all in all, if you just look at the whole stuff from 30,000 square feet view, you will find AI. If you peel it off, you will find it machine learning. If you peel off machine learning, you will get mathematics, you will get information theory, you will get lots and lots of data. And if you even peel it off, then probably you will get simple mathematical rules. So I want my machine to pick up those simple mathematical rules, and on the basis of that, I want my machine to predict certain things. Now there are three kind of machine learning algorithm which we generally have. The one is called unsupervised learning, the second one is called supervised learning, and third one is called reinforcement learning. Now this unsupervised learning is where we learn the things by our own. For example, in your school you might have played this activity wherein you have got different shapes, and you might have seen that a lot of kids also start playing those things, right, where they are identifying the patterns, where they're finding the similar kind of object and grouping them together, right? These are the things which you learn by your own. You can identify that this shape has got 3 sides and the other shape also has got 3 sides. However, you are not able to define them, but you actually can cluster those information. Now, just to give you an idea, how would you identify red color without defining the red, right? That's where, which is very challenging. And if I say you need not to use a word red over there, but you need to define it. Just try defining the red color without using a red or pink or white color. Then probably it would be a difficult task for you. Somebody has given you some color, and then you identify this is the same color which I have seen earlier, and I call it as red. Right? I can cluster out the things. I can find out the similar patterns in the things, and I can cluster them together. This is called unsupervised learning. The second kind of learning is very, very popular, and 95% of our learning happens through this. This is called supervised learning, where I have some data and I label that information. So human also learn 95% of the time. Human also learn from the supervised learning. So if I'm like showing my kid some information and I'm labeling that information as dog, I'm showing some information as another animal like cat, 20 days in a row, I'm just showing that information and I'm labeling that information as cat. Now what happens is my kid understand the difference between dog and cat, and when an unknown animal comes into the picture, he or she can identify whether it is a cat or a dog based on the patterns that he might have identified. So these kind of learning is very crucial, and this learning is one of the strongest learning. Whatever you learn is 95% of the time it is supervised learning. So what is good behavior and what is bad behavior in terms of human analogy, you can understand. Somebody is labeling that information for you. How to eat is somebody is labeling that information. What is the good behavior or the bad behavior? Similarly, machine also learns by labeling that information. So you give some data, you label that up. You give another data, you label that up, and you give multiple data sets to machine, and you just label up that information. And when unknown data comes in front of machine, whatever assumptions machine has created, machine will test the future data on those assumptions, and based on those assumptions it will spit out the label, whatever it understood, right? So for example, if XYZ happens, then it's a profitable thing. If ABC happen, then it's non-profitable things. So I've made my machine understand about this, and what happens when something happens, something like XYP, then probably machine will identify the pattern and will say it's a profitable thing, because what it has learned that if XYZ happened, then it's a profitable thing. If right now, if it is XY and not Z but P, then probably it could be the profitable thing. So this is how machine learns. The third kind of learning is very, very I would say easy as well as complex at the same time. Why? Because this learning is involved and it's been created, or you can say influenced by human learning from the experiences. For example, this learning in which machine tries to create its own rules, right? It sees the environment, and on the basis of environment it changes the pattern. When I say it changes the pattern, it means that it identifies some object on the basis of that it learns from that. It sees the environment and perceives the environment and take action against it. If you think of reinforcement learning, it works like this. So you have a machine and this machine, this is my machine, right? I would call it as machine, and machine has got some output over here, and this output is on the basis of environment. It sees environment, right? And you also have got some input over here, which is typically a rule based system. And don't worry about this diagram, I'll just make you understand. So what this machine does is it sees the environment, it perceives the environment, and then backfeed this information to the input, right? This is how it goes. It backfeeds that information, and your input changes, and again machine picks up that changes input and then start working on that part. So that is something is being done by machine. Now this is how does it work completely. I would just try to make you understand. For example, let's say, all right, so let's understand, say I have created a vacuum cleaner, and this vacuum cleaner, this is called VC, and this vacuum cleaner can move in the room, right? And it can go in any direction, and there is some dust, right? And this is where some dust is, and this is where some dust is, random places some dust is there. Then I would say, hi vacuum cleaner, would you like to go to this direction? And after going into this direction, it will perceive this information that it cannot go beyond because there is a wall, which means it is actually looking at the environment. It is looking at the environment through sensors or through cameras. It understands that it cannot go beyond, and then I have created a rule for it that you go to the to forward, and whenever you get stuck, take left, right? So this is rule number one. Rule number one is move forward, and the rule number two is that you should take left. Now this is where the if else programming works, right? So take left if obstacle is there, right? Then there you have to do the programming, that how much distance is there from the obstacle and so on and so forth, and then it will take left, right? It will take left over here, and every time it takes every second it has to run one more rule. If dust is present, start suction, right? And the third and the fourth rule is there, if dust is not present, then stop suction, right? So what will happen, it will take left, and it will see now it has perceiving the environment over here, that there is a dust over here, and as soon as it identifies the dust, it identifies that there is a dust, it perceives the environment, it sees the environment and understand that okay, there is a dust, I need to start suction. And once it starts suction, this portion over here is cleaned up, and then it moves next, and then it identifies that, you know what, there is again a wall, I will take left, then over here I'll take left, over here I'll see the dust, I'll suck it, and then I'll take left, and so on and so forth. And soon it will be able to take a round of the computer, like the whole system, and it can actually clean up the floor. Then you can again take one rule. If one round is clear, if one 360 round is clear, 360 degree round is clear, then take left 1 meter before, right? You write 1 meter before. So next time when it come over here, it will start taking this row, and then once it is completed, it start taking this row, and so on and so forth. I can write many rules for this vacuum cleaner, which is filled by artificial intelligence, or moreover reinforcement learning. So identifying dust as a dust is a work of supervised learning, and reinforcement learning, by looking at the environment, you are started perceiving that environment and changing the rules. Now over a period of time, I want, now say my my vacuum cleaner is bump into this wall, and I want my vacuum cleaner not to bump into the wall, then I would write a reward table. I would create a reward table. Now in this reward table, I will have some positive rewards, and then there will be some negative rewards. I will be writing some negative rewards over here. And how would this work? Every time my my vacuum cleaner does something wrong which is not expected out of it, I will give some numbers over here, and every time it does the right thing, I'll give some numbers over here, right? So, and I also write one more logic, which is the sixth logic over here, that maximize positive reward table. You have to maximize positive reward table and don't do anything with the negative reward table. Now with all these logics built in together, I would be able to define the complete logic, or I would be able to define the complete the logic for my my whole system. And this will make a lot of sense, because I want to create a device which is not only following the rules, it is actually making the smart decisions. And very much like a human thing, when we try to make a human understand, how would I say, we try to punish, or we try to give negative rewards to our kids when they do the wrong thing, and when we also try to give positive rewards in some sort of encouragement in terms of chocolate or some sort of gifts, so that they gets encouraged to do the right thing. So which very much like that, we also create machine learning algorithms. So what happens, all in all, I have a machine. Again, I would say, I'll draw this. I have a machine, right? I have a machine, and it perceives, it gives me the output based on the environment it sees, and whatever, if environment changes, it backfeed this information into the input. This is where the input is coming in, and backfeeds this information in input, and on the basis of that, it changes its output, the way it is working. And once it changes the output, environment changes, then this information is again backfeeded, and so on and so forth. It keeps on working that way, right? So I hope you're getting this logic over here, what exactly, or how exactly this whole machine learning algorithm works, and how we design several other things as well. So I hope it is making sense to everyone. Now for us, it's very easy to see the pictures, and after seeing the pictures, I want to identify multiple things. But for machine, we have to pass on this data, and this is how machine understand everything. So we see a picture, and machine understand this as a number. Machine understand this as a number. It has got data only. It can understand only data, nothing else. It just doesn't understand anything else. So this is very, very typical for us to understand, because machine just doesn't look at the images. It looks into the data, which are mostly in the form of numbers. Most of the time it is in the form of numbers. And very much like human, like for example, if I shown something to my kid, or my to any newborn, or I would say not newborn, or any child, if I just show something images, it will create some assumption that it has got 4 legs, it has got a tail, this is how it looks like, this is how it creates sounds and everything. The kid creates certain assumptions after looking at this. However, in machine case, these assumptions are mathematical assumptions, and these mathematical assumptions are nothing but the models of machine learning. So we pass on some training data, like 20 days I'm showing something to my kid. This is training data, and with that training data, machine has created some mathematical assumptions, and it learned from that data. And in the future, when I on 21st day, when I'm passing on a testing data to test the knowledge of the machine, it actually it's nothing but the futuristic thing. I can pass on this data to my machine, and based on the model which has been created by the training data, this testing data will be assessed on this model, and then it will predict whatever the category of that animal is. So this is how whole machine learning things works, and I hope you understand this. These assumptions over here in machine are nothing but the mathematical assumptions, nothing more than that. Now in this, machine learning is being used in many fields. So if you used in like when you're collecting data, you call it as data mining. In statistics, you call it as inference or estimation. In engineering, you call it as pattern recognition. In electrical engineering, you call it as signal processing or induction or optimization. There are various names for machine learning algorithms. However, they're doing the similar kind of things. So I hope you understand what is machine learning, and you've got the clear-cut idea about that machine learning is a branch of artificial intelligence which concern with the construction and the study of the system which can learn from the data. And this is how we make our machine understand what is what. Be it a text, be it a voice, be it a picture, be it an image, or be it any Excel sheet or text data. The machine learns in the same way. Alright, so we've understood the machine learning thing, and in the next video we're going to talk about the applications of this machine learning. Trust me guys, we are surrounded with machine learning algorithm, but it's just that we don't realize it. I'm going to uncover various patterns or various things which you might have think of in machine learning. I'll see you in the next video. I have got very exciting things coming up. See you next.